We're really interested in solving this temporal credit assignment problem. As we will see as we talk later on in the course, this sort of issue comes up again and again and again. But I didn't really want to talk about that in any great detail. I just wanted to make certain that people saw the difference between supervised learning and the sort of problems that we're trying to solve now, that really it has to do with sequences and time. What I want to do is focus a little bit more on rewards. And in particular, I want to look at the little grid world that we've been playing with so far and think about how we would learn how to get from our start state, which we always started over here, over to one of the +1 or the -1, depending upon the kind of rewards that we see. So let's push on this rewards notion for a minute if we think about how NDPs are made up. And I'm just going to write down for you what the reward is for the states in this particular grid world, okay?
Yeah.
So let's say I'm going to set the rewards to be equal to minus 0.04. So the first thing I want to do is I want to make sure you understand what I mean by this. So what I mean when I write this down for this particular example is that the reward that I'm going to receive in every single state is minus 0.04, except, of course, for these two states, which I've already labeled as +1 and -1. Okay?
All right. So it seems like you should just never ever move then, right?
No, I don't think that's true. Let's think about that for a little while. So if I set this reward to be minus 0.04, and you're starting out here in this state, and you have to keep living, you always have to take an action, right? That's the way I've set this up. And you don't get to stop until you reach either +1 or -1. We'll call these terminating or absorbing states. Once you reach into one of these things that ends the game, what would having a small negative reward like this encourage you to do?
It's making me think about kind of walking across a hot beach. Because like each time you take a step, you're going to get a little bit of punishment. And the only thing that ends it is if you can get into that nice, cool ocean. And then you get a +1 for that and the minus 0.04s stop.
Right. So that means, so wait, how would you put that another way? It sounds to me like what you're saying is by having a small negative reward everywhere, it encourages you to end the game.
Yeah. I agree with that.
Okay, yeah, and I think that's exactly right. I like that analogy a lot. You're in well, it's not a very hot beach. It's just a, slightly unpleasantly warm beach. And you really want to hurry up and get into the ocean. And in fact, you want to hurry up and get into the ocean, even though on your way to getting to the ocean, you might step on some glass. The -1 is. So let's go back to this notion of policy, of mapping states to action. And let's think about us being in this world where you have a reward of minus 0.04 everywhere except in the absorbing states. What do you think the best set of actions are to take in these different states? What do you think the best policy is? Actually, before you tell me, let me write down what the actual policy is. I'm not going to tell you how we get here, but I'm about to write down the policy that's sort of the best one to take in a world where you have these sets of rewards. Okay?
Sure.
Okay, you see this, Michael?
Yeah, and it makes a lot of sense. Like if you're basically heading towards the rewarding state, the green state.
Right. So if I start out here in the leftmost bottom state, basically it says go up and then go to the right, which coincidentally is the policy that we had found before.
Cool. There's a couple spots that are a little bit strange, though.
Like what?
Well, I'm thinking about the one not directly under the -1. That makes sense to me. But the one, it takes you now to a position where it seems like you want to go straight up to the goal, but yet it's going the long way around. It just didn't see the goal?
No, that's not it at all, because the way we're going to learn this, so this is a global policy, and I'm just telling you that it's the optimal policy given the rewards. So let's kind of work out why going to the left makes sense here. Well, so here's my argument. What this basically says is take the long way around. Yes?
Yeah.
But by taking the long way around, what's happening? Well, on the downside, I'm going to pick up a little bit of negative reward for a while. 1, 2, 3, 4, 5, 6 or so, which is something like -0.2, -0.3, something like that, right? But by doing this, I avoid ever getting into a state where I might fall into the -1.
Ah, because it's stochastic.
Right, it's exactly. The stochasticity means that if I'm in this state here, no matter what I do, if I go up, I have some chance of moving to the right and falling into the -1. It's a relatively low chance, it's only 10%, but it works out that moving from here to here, the probability of me falling into here is too high compared to the sort of near impossibility of me ending up falling into -1 if I can follow this path.
Interesting. Okay, I guess that makes sense. That's cool.
Which actually suggests sort of the point that I want to make here, which is that minor changes to your reward function actually matter. So if we had a slightly different reward here, say not minus 0.04, but something else, you might find that some of these decisions would be different. Think you can see that?
I mean, at the level that I'm understanding it, it seems like if it's 0, that then it's in no particular hurry. If it's minus something big, then maybe it's in a bigger hurry. But I don't see exactly what the difference is going to be.
Okay, so let's see if we can help you see the difference by making you take a quiz.
Aha!